Hi and welcome to my channel. Welcome to this tutorial session. Here we are given the radical equation root x plus 4 minus root x minus 1 equals 1 to solve for the solution set, to find the solution set. We have to be careful. This is a radical equation that we might just go ahead and solve and end up with some values which are not valid. Okay, if we just go ahead and solve equations of this nature without first of all checking our interval of validity, we might end up concluding with solutions that are not valid. So to be able to handle that difficulty, what we need to do is to find the interval of solution. What we call the interval of solution. Interval of solution. Our interval of solution will be those set of values that will be valid for the radical root x plus 4 and those set of values that will be valid for the radical root x minus 1. So what are the values of x that will make this radical expression valid? Okay, remember this is square root, and square root does not exist for negative numbers. So for this square root of this expression to be valid, then the expression here must be greater than or equal to 0. X plus 4 must be greater than or equal to 0. And so which are those values of x that will make this root x plus 4 valid? The values of x that will make those root x plus 4 valid will be all values to the right of negative 4. All values to the right of negative 4 will make this radical expression valid. All right. So we also look for values of x that will also make this other radical expression valid. The values of x that will make this other radical equation valid. Again, this is square root sign, and square root is not defined for negative values. So this expression here, x minus 1, must be greater than or equal to 0 for this root x minus 1 to be valid. And so the values of x that will qualify this will be all values of x to the right of 1, including 1. All values of x to the right of negative 4, including negative 4. Now, what is therefore our interval of solution? Our interval of solution will be those set of values of x that lie in the intersection of this set and this set. Those set of values of x that are here and are also here. How do we get that? We can work that out using number line, intersection of these solutions on the number line. This very first solution, this is always 0, we'll have 0 in the middle. This is negative 4. This first one says all values to the right of negative 4, including negative 4. That's why we have shaded this. It means negative 4 is included. All values to the right, including negative 4. And then this other one says all values to the right of positive 1. This is positive 1. All values to the right, including positive 1. So we also share that. All right. So all values to the right of positive 1, including positive 1. Okay. So where is our intersection? We see that this starts from negative 4 and goes. And you can see that positive 1 is also here. So positive 1 is included in this solution set. All right. But if you look at this other solution set, all values to the left of positive 1, they are not packed. That means values from negative 4 right up to less than 1, they are not found in this solution set. But all values from 1 upward, they are also found here. So the intersection will be indicated as such. Okay, this will be the zone where we have all solutions valid. Valid for this and for this. They are found here. So our solution, our interval of solution, our interval will be all real values of x such that x is greater than or equal to 1. So this is the interval in which we expect to find the solution of that our radical equation to lie. Okay, that done, we now go in now to solve our radical equation. Our radical equation says we have root x plus 4 minus root x minus 1 is equal to 1. Okay, we want to find that solution set. This is negative root x minus 1. Let us take it from the left hand side to the right hand side. So we end up with root x plus 4. When we take this one, it becomes positive. So we're going to have positive root x minus 1 plus 1. All right. So the next thing, we remove this radical sign here, this square root sign, by doing the opposite operation of square root. The opposite operation of square root is square. So we square both sides. We square here and we square there. Whatever we do to one side, we must always do to the other side. This square cancel square root and we have x plus 4. Here, we don't come here to say this square cancel this square root like we did here. This is an expression of two terms. It's like what we do when we have expressions of this form. A plus b all squared will be a squared plus 2ab plus b squared. So we have to take note. All right, where our a is root x minus 1 and our b is 1. So we come over here, we applied it there. We're going to have root x minus 1 squared. This is a squared plus twice their product. We'll just do root x minus 1 multiplied to 1 and then plus 1 squared. That's what we get. All right, so let's simplify further. Now here we can say power 2 cancels the square root. It gives us x minus 1 plus 2 root x minus 1. 1 squared is 1. Alright, so x plus 4 gives us all of that. Now we have negative 1 plus 1, that should be 0. So we have x plus 4 is equal to x plus 2 root x minus 1. Negative 1 plus 1 is 0. Now we have x on both sides. The x's just cancel off because if we have to take this one this way, it will become x minus x, which is 0. Or we take this one this way, it will become x minus x, which is 0. So we end up having 4 is equal to 2 root x minus 1. Right. Now that we have this alone here, we now proceed to remove the square root sign by doing the opposite operation of square root, which is square. We have to square both sides, just like we did up there. So when we square both sides, we obtain 4 squared is 16. This square will affect this and will affect this separately. So we have 2 squared into the square of the root of x minus 1. All right, so we have 16 is equal to 2 squared is 4. And then here, the square will cancel the square root. We have x minus 1. Now, let's open the parentheses. So we have 16 is equal to 4 multiplied to x is 4x. 4 multiplied to negative 1 is negative 4. All right, now let us bring negative 4 from the right-hand side to the left-hand side. It becomes plus 4. All right, it's equal to 4x. 16 plus 4 is 20. It's equal to 4x. Remember, we're solving for x. So to remove this 4, all we need to do is to divide both sides by 4. So that the 4 goes away. 4 here 1, 4 there 5. So we have x is equal to 5. So we have arrived at the solution x equals 5. So it just happened that in this our exercise, we have just one element in the solution set, which is x equals 5. So here we see our solution set. Therefore, our solution set will be is just the singleton 5. Our solution set is the singleton 5. But we have to check to see if what we have there as solution set is valid. How do we check that? Let's go ahead and check it to see if our solution is valid. Let's check if our solution is valid. Remember, we had root x plus 4 minus root x minus 1 is equal to 1. Let us check if we put x in the 5 in the place of x, we are going to have a true statement for the left hand side and the right hand side. That is, we want to see if we put 5 here for x, if we obtain 1. Let's go ahead. Wherever we see x, we put 5. So we're going to have root 5 plus 4 minus root 5 minus 1. Okay, 5 plus 4 is 9. So that gives us root 9 minus 5 minus 1 is 4. Root 4. Root 9 is 3. Root 4 is 2. 3 minus 2 is 1. So is it equal to 1? 1 equals to 1, true. So we have arrived at a true statement. Therefore, our solution set, which is the singleton 5, is the valid solution to our question.